currently working towards my PhD in SoCoRI University in the Department of Information Technology and Engineering. So in this case, my research interests include data analytics. Currently I am working towards various data sets like energy data sets, greenhouse data sets, and intelligent transportation data sets. So in this paper, industry energy consumption prediction using data mining techniques. So this paper deals with energy data. I have predicted the energy consumption for daily industry. So I have used basic machine learning algorithms, namely linear regression, CART, that means classification regression trees, support vector machine, k-nearest neighbors, and random forest. So before that I have identified extra features from the data sets, and I have did feature engineering to extract additional features, and I have fine-tuned the models with the best hyperparameters, and I have compared the models which is the best. So for evaluating each of the model, 4 evaluation metrics such as root mean squared error, mean absolute error, mean absolute percentage error, and coefficient of variation. So the models are evaluated by using these 4 evaluation metrics. So this is the introduction about this. So the data set is from Daewoo Steel Industry, that is small scale industry in Guangyan. So these are the data variables present in the data sets. Here the dependent variable is the industry energy consumption, that means usage. The data set is for every 1 hour. So it's corresponding lagging and leading current reactive power, and lagging and leading power factor, and carbon dioxide emission. These things are recorded in the cloud-based data systems. So these data are stored in a cloud-based data system and is available, and it is monitored by KIPCO. So the original data set consists of 1, 2, 3, 4, 5, 6 fields, and number of seconds from midnight, week status, day of week, and the load type. I just merged with the data sets. Here the future engineered variables are NSM, that is number of seconds from midnight. That means from 12 o'clock to 1 o'clock, each and every 1 hour, how many seconds. That's like, I don't want to use that hour variable. So because the energy variable is so varied, I want to use that interior fusion of the hour variable. So I have managed it to NSM. So week status and day of the week in this. So in order to set the proper cycles in the data sets, I have used week status and day of week. This is the 1 year data sets, like in 365 days I have collected the data sets, and this corresponding load type, like from morning is 9 o'clock to evening 6 o'clock, the load type will be medium, and the overall the night time the load type will be low. So during the interval times, like the lunch time and everything, the load will be medium. So these are the load types, and the corresponding load types and timings will be given in the paper. I have mentioned in the paper. So these are the data sets. Here the important thing is that the thing I am going to predict is industry energy consumption, that is usage. All the other things are independent variables. The dependent variable is usage. So this is the energy heat map for that energy consumption. As you see, I have did for 1 week, or it's like 1 week, 1 full week, and I have plotted against each and every hour. That dark red spots are the maximum electricity consumption of the step, and the light yellow color are the hours with medium energy consumption between like 0 to 100. So as you see that, during the weekends, that means Saturday and Sunday, the energy consumption is comparatively high, comparatively low compared to those in weekdays, and the working hours is from morning 8 o'clock to evening 8 o'clock. So at that time the energy consumption is comparatively high. So these patterns are analyzed, and I used this information from these patterns, and I extracted these cycles, and I have mentioned, and I have merged the data with the data sets, and I have compared it, and I have combinedly used for that evaluation. So this is the whole visualization of the data set, like for first 5 weeks. So in order to test the data variables, like for prediction, I have just used the feature selection algorithm. So in order to test the algorithm, I have introduced two variables like RB1, random variable 1 and random variable 2. So this feature algorithm detects the less important variables. So as you see, that Boruta variable has three variables like shown in blue color, that shadow mean, shadow minimum and shadow max. Like the random variables are random variable 1, random variable 2 are shown in red color. It eliminates the random, like unnecessary variables. So this proves that the data variables used in this data sets are highly needed for prediction. So as this feature selection gives the importance of the feature, but it is not related to the prediction performance on things. So I have used the recursive feature elimination algorithm for ranking the features. So this algorithm, this elimination, this kind of feature elimination eliminates that unnecessary data sets, as you can see, and it's also ranks the data sets from number 1 to number 18. So finally, after converting the categorical variable into dummy variables, the total number of data independent variables is 18. So, and all the 18 variables are needed for the prediction. So, all the 18 variables are needed for reducing the RMSE value. So, as you can see, the plot that one filled dot, it shows the number of variables needed for RMSE reduction. All the 18 variables are needed for the RMSE reduction. So, all the 18 variables are used for prediction. So, this is random feature elimination algorithm using random forest I have done for feature selection. So after preparing the data set, preparing and ranking creating additional features and ranking the features, its next step is to develop the models. I have used 5 models like linear regression, CORT, KNN, SVM and random forest. So each and every model has to be fine-tuned with the best parameters. Each and every model has its own hyperparameters. Like in this, the CORT model, like classification regression tree, has the hyperparameter CP. So I have used tenfold cross-correlation and I have searched the best result. So which point after that it will be, the error value will be constant. I have tried all the best possibilities from 0.00 to 0.30. As you can see, from 0.20 the error value remains constant. So that value 0.20 is chosen as the optimal value for CP in this data set. So in case of SVM model, like sigma and cost need to be optimized. So I have used all the possible values from 0 to for cost I have used from 0 to 13, and for sigma I have used 3 possible values like 0.1, 0.35 and 0.4. So here the lowest combination of hyperparameters is the sigma 0.1 and cost 13. So that is the fine parameters, optimized parameters for SVM radial model. So these are the best search results for all the models are fine-tuned with tested with tenfold cross-correlation. So this is the optimal parameters for SVM radial model. So in case of random forest, 2 hyperparameters need to be tuned, like number of trees and number of predictors, like number of optimized, number of independent variables need to be considered. Here, as you can see, the number of trees after number of trees 300, the error values remains constant. So the number of optimized values for number of trees is 300. And in case of randomly selected predictors, so the total number of independent variables is 18. So from 10 to 18. The error values remains constant, so the optimized value for n is 10. It is chosen as the optimized value is 10. In case of KNN model, only one variable need to be optimized, like number of neighbors, how many variables needed to, because in case of KNN, the nearest neighbors are, the values of the nearest neighbors average is taken as the predictor variable value. So in this case, 18 variables, I have the best, the number of neighbors needed is 2. So in case of KNN model, the optimized value is k. 2 neighbors are enough to predict the dependent variable. So optimized like this, where all the models are after finding the best hyperparameters, all the models are trained with the best hyperparameters. So actually 4 evaluation indices like RMC, MAE, MAP, MCV used for evaluation. So these are the training and testing metrics. Like so RMC, MAE, MAP, MCV, all the 4 are error values. So as you can see, random forest gives the least, that means less error values. So in this study, I have considered the random forest the best tool for predicting industry energy consumption. So in case of GLR, that means generalized linear regression, it produces highest result, like highest RMC values and highest error values. So our random forest is best proven to be the best tool in predicting energy consumption in this paper. So my contribution to this work is I have created the data set, I have identified the additional features, and I have modeled 5 regression algorithms. And I have used 4 evaluation metrics for evaluation. So the future work is actually in future work in the extended work I plan to use the model called rule-based model called Q-based. That's never used that in this energy consumption field. They have never used a Q-based model, and that is going to be and Q-based algorithm gives the less error values than random forest. So I am going to use that model in the next paper. So thank you.
Yeah. Is there any questions on the floor?